Let's talk about the cross-aldol condensation reaction. Before starting, I want to show you here some examples of the normal type of aldol condensation reaction, in which you can see that the same type of aldehydes and the ketones are reacting with each other, resulting in the formation of the aldol products. Like in the first reaction here, the molecule of acetaldehyde is reacting with itself. I mean, the second reactant is also a molecule of acetaldehyde here, giving what? Giving the aldol product. In the same way, in the second reaction here, another aldehyde, that is propanol, is reacting with a molecule of propanol, means the same aldehyde, once again giving the aldol type of product here. Likewise, in case of ketones, for example, the acetone with acetone, but-2-one with a molecule of but-2-one, these are also giving the aldol type of products here. This means when the same type of aldehydes or the ketones are reacting with each other, this corresponds to the aldol type of condensation reaction. Now let us see what is meant by the cross-aldol type of condensation. For that, what we can do here is we can try to react different kinds of aldehydes or different kinds of ketones. For example, from this set of reactions, let us try to react the molecule of acetaldehyde, I mean this one here, with the molecule of propanol. In that case, this type of reaction will be known as a cross-aldol type of condensation. This means the aldol reaction in between different kinds of aldehydes or different kinds of ketones is known as the cross-aldol type of condensation, right? Even on this side, when acetone is made to react with a different kind of ketone molecule, let us say the but-2-one, even in that case, the product will be the cross-aldol type of product here, right? So that I can now write here that acetaldehyde upon reaction with propanol will be giving me a cross-aldol type of product here. Cross-aldol type of product here. In the same way, when a molecule of acetone is allowed to react with a different kind of ketone molecule, let us say the but-2-one, even in this case, it will be giving me a cross-aldol type of product by a reaction known as the cross-aldol condensation, right? So it will be once again a cross-aldol type of product here, right? Now the story do not ends here. One more thing I want to tell you people here is that not only with in between different kinds of aldehydes or different kinds of ketones, but also if we try the reaction in between some aldehyde, let us say this is an aldehyde here, and if we try to carry out the aldol reaction in between some aldehyde or a molecule of ketone, let us say this one here, or in between this aldehyde, I mean the propanol, this aldehyde or this ketone here, that is but-2-one, even in that case it will be known as a cross-aldol type of condensation. Okay, so I will be erasing everything else from here, from this slide, but I will be keeping the molecule of this aldehyde, this ketone, and this aldehyde as well as this ketone here, in order to show you that the reaction between some aldehyde and a ketone also corresponds to a cross-aldol type of condensation reaction, right? So you can see here on your screen that when the reaction will be in between a molecule of acetaldehyde and some ketone molecule, let us say the acetone, this will give rise to a cross-aldol type of product formation here. Okay, so it will be known as a cross-aldol type of reaction. In the same way, when this will be reacting with, I mean the propanol will be reacting with but-2-one, which is actually a type of a ketone molecule. Once again, we will be having here the cross-aldol type of reaction, and the product will be the cross-aldol type of product here, right? So moreover, these two reactions are not fixed. even this can also react with, this aldehyde can also react with the other ketone here, which I have shown here below, the butone, as well as this will also be giving me the cross-aldol type of product here, right? And from this choice of reactants, one more possibility is also there, and that is what? That is the reaction of the propanol with the acetone molecule. And once again, because it is the reaction between some aldehyde and a ketone, so it will also be giving me what? It will be giving me a cross-aldol type of product formation, right? A cross-aldol type of product formation, right? So this means, in nutshell, I can say here, if the reaction is taking place between same type of aldehydes, which you can see here, these two aldehydes are same, or in between the same type of ketones, which you can see here, in that case it will be resulting in the formation of an aldol product, right? You can see here the different R groups. For example, R here, then R1, R2, R3, as well as R4. They are not same, they are totally different, right? So on the right hand side of the screen, you will see that when the reaction takes place in between different kinds of aldehydes, because this aldehyde here is different from this second aldehyde, because you can see here the R1 is not equal to R2, which I have shown here. The R1 is not equal to R2. So whatever reaction will be taking place here in between different kinds of aldehydes, it will be giving a cross-aldol type of product formation, right? In the same way, as far as the ketones are concerned, you can see here that this ketone and this ketone, they are also different. So this will also be giving the cross-aldol type of reaction, not only in between the different aldehydes or different ketones, but also in between some aldehyde or a ketone, which you can see here. This is what? This is a molecule of aldehyde here, right? And this is what? This is a molecule of ketone. Okay, so this will also be giving a cross-aldol type of reaction, right? So let me also write here that these are what? These are the different type of aldehydes, and below to this, these are what? These are the different type of ketone molecules, right? So now this must be clear to all of you that the same aldehydes or the same ketones gives the aldol product formation. On the other hand, the different aldehydes, different ketones, or the reaction between some aldehyde or a ketone always gives the cross-aldol type of reaction and the cross-aldol type of product formations, right? Now you can consider this cross-aldol reaction because it is taking place in between a molecule of acetaldehyde, which is actually a type of an aldehyde, and a molecule of acetone, which is actually a type of a ketone, right? So obviously it is a good example of a cross-aldol type of reaction. Now, before we go into the detail of this cross-aldol type of condensation reaction, one thing which I want to remind you people from the previous video that was there on the normal type of aldol condensation, I want to remind you that in case of aldol condensation, the bond formation that was there, it may be some acid catalyzed mechanism or it may be through some base catalyzed mechanism, but one thing is standard. The bond formation always takes place in between the alpha carbon atom, because this, in this molecule here, this is the carbonyl group, and obviously this carbon atom here is the alpha carbon atom, right? And moreover, you can see here this is the same molecule of aldehyde. This is also a molecule of acetaldehyde. Let me write here, this is a molecule of acetaldehyde, as well as this one here is also a molecule of acetaldehyde. Okay, so no doubt that this reaction here that is occurring may be in the presence of some base or some acid here. This is an example of the aldol condensation because the molecules are same here, right? The important thing which I want to remind you is that in case of aldol condensation, the bond formation is always in between is always in between the alpha carbon atom of one of the reactant molecule and the carbonyl carbon of the second reactant molecule, right? So after this aldol condensation, the bond formation will be something like this here, right? So you can see here the new bond formation, that is this one here, it is taking place in between the alpha carbon atom of the first acetaldehyde molecule, and this is what here, this is the carbonyl carbon of the second acetaldehyde molecule, I mean this one here, right? So this is like a standard thing. The bond formation will always be like this as far as the aldol or the cross aldol condensations are concerned, right? So now let us try to solve this cross aldol reaction here, that is in between some aldehyde and then a ketone molecule, right? You can see here I have written this line here at the bottom, that in order to make you remind once again that the carbon-carbon bond formation will always be in between the alpha carbon atom of the first molecule and the carbonyl carbon of the second reactant molecule, right? So if you look here in this combination, that is the acetaldehyde plus acetone, if we say that this is the carbonyl carbon here of the acetone molecule, obviously this will be the alpha carbon and the hydrogens will be alpha hydrogens here. The acetone molecule here is having two different alpha positions. Okay, not different, these are having two alpha positions which are exactly same, right? So it doesn't matter whether we are carrying out the reaction by this alpha position or this one here, because these are exactly same. It is a symmetrical molecule, right? On the other hand, you can see here this is the molecule of acetaldehyde. So the first reaction will be what? It will be in between the alpha carbon atom of the acetone molecule, let us say, and then the carbonyl carbon of the acetaldehyde molecule, right? So this is the first possibility here, that the alpha carbon atom of the acetone will be going to react with the carbonyl carbon of the acetaldehyde, resulting in the formation of a new bond in between this carbon atom and this carbon atom here, which I can show here. The product will be something like this here, right? So you can see here the new bond formation here, that is taking place from the reaction in between this carbon and this alpha carbon atom here, right? After that, there is also a second possibility, and that possibility is what? That because the alpha position is also present here in the molecule of acetaldehyde, so what could happen is that this alpha carbon can now also form a bond with the carbonyl carbon of the acetone, right? Initially what was happening? This alpha carbon atom was making a bond with the carbonyl carbon of the acetaldehyde, but this time the alpha carbon atom of the acetaldehyde is forming a bond with the carbonyl carbon of the acetone molecule, right? In that case, let me show you the product formation will be like what? It will be CH2 C double bond OH. This part here of the product molecule is from the acetaldehyde, and this will be forming a bond here. A new bond formation will be there in between this carbon and this carbonyl carbon here, right? So it will be like this. I mean this will now become single bond. This will now become single bond here, O and H here, and because it is having two methyl groups, the first one and the second one here. So let me join here the first methyl, and here will come the second methyl in this way, right? So in this type of cross-aldol reaction, if this is the first possibility, here, this is the first cross-aldol product, there is also a possibility that this type of cross-aldol product formation can be there, right? Now the reaction is not over yet. The reason being because this is not the single acetaldehyde molecule in the reaction, and neither the acetone molecule is single in this reaction here. This means what? That a lot of acetaldehyde molecules are present. So I am just showing you the second acetaldehyde molecule, and then also there is present a third one here. The third acetaldehyde molecule is present, and like this many more lakhs and crores of acetaldehyde molecules are there in that reaction, right? In the same way, even this acetone molecule is not alone in that reaction mixture, but a second molecule of acetone, which I can show here, and then a third one, the third molecule of acetone, and like this, once again, millions and billions of acetone molecules are present in that reaction mixture. So I will be writing here many more acetone molecules are also present, right? Now the idea is why I'm drawing the different acetaldehyde molecules and the acetone molecules here, because I want to tell you that there is also a possibility of the third reaction here. There is also a possibility of the third reaction, as well as there is a possibility of the fourth reaction giving rise to a fourth product here, right? So what are those two possibilities, right? Those two possibilities, I mean those additional two possibilities are that the acetaldehyde molecule, you have just seen that it is reacting, this acetaldehyde molecule is reacting with what? It is reacting with the molecule of acetone in two different ways. In one case, the alpha carbon atom of the acetone is reacting with the carbonyl carbon of the acetaldehyde, giving this first product here. In the second possibility, the alpha carbon atom of the acetaldehyde is reacting with the carbonyl carbon of the acetone, giving the second cross-aldol product formation, right? But because other molecules of acetaldehyde and then other molecules of acetone are also there in this reaction, so what I am trying to say is that the acetaldehyde molecule can also react with itself. In the same way, the molecule of acetone also can react with itself, giving two more products here, right? So if I say here that the alpha carbon atom of this acetaldehyde molecule is reacting with the carbonyl carbon of a same kind of second acetaldehyde molecule. In that case, the third product formation will be something like this. I mean CH3, I'm drawing this molecule here, single bond C, this will now become a single bond OH here, and one H is already attached to this molecule of acetaldehyde. Then I am showing here the new bond here, this is the new bond here, and then I will be drawing here this molecule of acetaldehyde. So it will go like this. It will be now CH2 single bond C double bond O and H here, right? So this is like the third molecule of this cross-aldol reaction, which will also be formed in this reaction here, right? In the same way, because a lot of molecules of acetone are also there, so there is a possibility that the acetone can also react with itself, right? So if we just say here that if this alpha carbon atom of this acetone is reacting with this carbonyl carbon atom of the second molecule of acetone, in that case the product formation will be something like CH3 single bond C. I am drawing this molecule here. This will now become a single bond OH here. Then one more single bond CH3, a new bond formation in between this carbon and this carbon here, which I can show here in this way. And then this is the carbon, I mean this one here, this carbon here. So it will be CH2 single bond C double bond O and CH3 here, right? So this will be the fourth product molecule of this cross-aldol type of reaction, right? So the whole idea is that if we will be trying to carry out the aldol, I mean the cross-aldol type of reaction in between a molecule of some ketone and an aldehyde, like in this case, it will be giving us a mixture of 4 different product molecules, right? And you can very well imagine that it is very difficult to separate such a complex mixture of product molecules, right? So we can say that this one here is a big limitation of the cross-aldol type of condensation. And why such problem is arising? The reason is quite simple, that the first reactant, if we say here that this is the first reactant molecule if this is the first reactant molecule, these two reactants are from the previous reaction. Let us say this is the first reactant, this is the acetaldehyde, and here you can see that this is the second reactant molecule, which is what? Which is a molecule of acetone, right? You will see here that both the acetaldehyde as well as acetone, both are containing the alpha carbon atoms and thus the alpha hydrogen atoms, right? You can see here this molecule of acetaldehyde, it is containing alpha carbons as well as the alpha hydrogen atoms are present. In the same way, the molecule of acetone is also having alpha carbon atom and then a lot of alpha hydrogen atoms are also there, right? So this is the main problem here, that is giving a mixture of 4 different products that both the reactant molecules, the first one as well as the second one, both are having their own alpha hydrogen atoms. Both are having their own alpha hydrogen atoms. So obviously this gives a possibility of 4 different types of combinations, 4 different types of nucleophilic electrophilic interactions. Why I am saying here the nucleophilic electrophilic interaction? This thing I have already discussed in the mechanism part, because whatever acid catalyzed or base catalyzed mechanism is there in the aldol condensation, which I have discussed in my previous video lecture, I have shown there that it is nothing but a nucleophilic and electrophilic type of interaction, right? And because here both the reactants are containing alpha hydrogen atoms, so there is obviously a possibility of 4 different combinations that is giving rise to 4 different products here, right? So now let us see that what is the solution of this problem. What we can do is we can think of a combination in which only one molecule, one reactant molecule is having the alpha hydrogen atoms. Like in this case here, I mean the acetaldehyde molecule here is having alpha hydrogen atoms. On the other hand, the other reactant molecule, that is benzaldehyde, it is devoid of any alpha hydrogen atom, means the alpha hydrogen atoms are not present in case of benzaldehyde. Because you can see here, if this is the carbonyl group, if this is the carbonyl group here, this carbon here is the alpha carbon atom and it is not having any alpha hydrogen, right? So we can think of such type of combinations in which out of 2 reactants, only one is having alpha hydrogen atoms, and by this we can solve the problem to half of its amount, right? So in the previous slide, if I go back here, both the reactants are having alpha hydrogen atoms. So this was giving 4 different products. This was giving 4 different products. We have just seen this reaction, 4 different products, right? But now if we choose such a combination in which only one reactant, I mean this one here, is having the alpha hydrogens and the other one is not having, in this case here we will see that this will be giving rise to only 2 different products here. It will be giving only 2 different products here. This means initially we were having 4 products and now we will be having just 2 products, right? So that is why I have just said that we will be able to solve this problem to half of its amount, right? So at least it will be quite easy to, it will be relatively easy to separate 2 different products as compared to a mixture of 4 different products, right? So one thing that may come to your mind, that why we are not taking both the reactant molecules which are not having any alpha hydrogen atoms, right? So in that case, I want to tell you that the essential requirement of aldol condensation or of the cross-aldol condensation is the presence of alpha hydrogen atoms. Okay, we cannot have such a combination in which both the reactants are not having alpha hydrogen atoms, right? So in that case, there is no chance that we can have either aldol or cross-aldol type of reaction, because at least one reactant should be having the alpha hydrogen atom. Only then the cross-aldol or the aldol type of reactions are possible, right? So this is the solution here. We should be choosing such type of combination. And now let us see what are those 2 different products that can be prepared from this type of combination in which one reactant is having the alpha hydrogens, and the second one is not having the alpha hydrogens, right? So we will see here that the reaction will proceed in this way. I mean, the first possibility is that the alpha carbon atom of the acetaldehyde, it will be forming a bond with the carbonyl carbon atom of the benzaldehyde molecule, right? So the product will be something like this. I mean, this is the benzene part of the benzaldehyde molecule, and then we are having one carbon atom, one hydrogen is also there, and this will now become a single bond OH here. I won't be discussing the mechanism again and again here. I have already discussed the mechanism in my previous video lecture. You can see from there that how this double bond will be converted into a single bond and one hydroxyl group here, right? So the new bond formation I can show in this way. This is the new bond formation, and this is going to this carbon atom, the alpha carbon atom of the acetaldehyde molecule, so that I can show here one CH2 single bond, C double bond O and H here, right? So this is the carbonyl, this is the carbonyl here, this is the alpha carbon atom, and this one here is the beta carbon atom. So this is what, this is some beta hydroxy, because on the beta position we are having a hydroxy group. This is a beta hydroxy aldehyde, right? So this is another name for the aldol type of product here, right? But because we are talking about here different kinds of aldehydes, you can see here this benzaldehyde is different from the acetaldehyde. So the product here will not be a aldol type of product, it will actually be a cross-aldol type of product, right? So it will be a cross-aldol type of product here. It won't be good that if we are calling it as an aldol product, because we are taking different aldehydes here, okay? And this whole lecture is all about the different kinds of aldehydes, different kinds of ketones, and an aldehyde or a ketone giving cross-aldol type of condensation, right? So this is the first possibility here. So this will be the first product in this type of cross-aldol reaction, in this type of cross-aldol reaction in which one of the reactant is having only the alpha hydrogens. The second one is not having, right? So this was the first possibility. If you look carefully on this combination of reactants, you will see that there is also present a second possibility. And what is that second possibility? Because a lot of molecule of acetaldehyde are there in this reaction. So I can draw here the second molecule of acetaldehyde, and the alpha carbon atom of this first acetaldehyde molecule, it can also react with the carbonyl of the second molecule of acetaldehyde, giving what? Giving a second type of product formation here, and which will be like this. I mean CH3, this one here is from this molecule, CH3C single bond OH here. This is also having one hydrogen, and then a new bond formation in between this carbonyl carbon and the alpha carbon atom of the acetaldehyde molecule, the first one, so that I can write here, I can draw here CH2 single bond, C double bond O and H here, right? So once again, this is also some sort of a cross-aldol type of product formation. So let me write here, this is also a type of a cross-aldol type of product formation, and it is the second product molecule which we will get in this cross-aldol reaction, right? Now if we say here that there are also present some other molecules of benzaldehyde as well. Let me draw here another molecule of benzaldehyde. This is containing one benzene ring, C double bond O and H here. Now you will see here that the cross-aldol type of reaction in between this benzaldehyde and this benzaldehyde won't be possible, because none of these benzaldehyde molecules is having the alpha hydrogen atoms. This is the alpha position here, it is not having any hydrogen. In the same way, this is the alpha position here, this is also not having any hydrogen, right? So this cannot react with itself, right? So in such a combination, I mean this combination here, the reaction of benzaldehyde that is not having any alpha hydrogens with acetaldehyde that is having alpha hydrogens, it will only and only be resulting in the formation of just two different product molecules, and we can separate them. It is relatively easy to separate two different product molecules as compared to four different product molecules which we have just seen how they will be formed in the previous reaction, in which both the reactant molecules were having alpha hydrogens, right? So in such a case, the cross-aldol type of condensation is not significant. We have to choose reactants carefully in such a way that only one of the reactant molecule contain alpha hydrogens, so that in that type of combination, if we try to carry out the cross-aldol type of reaction, it will only and only be leading to the formation of two different product molecules that can be easily separated, right? So this is all about the cross-aldol type of reaction. Thank you so much.